The natural world is a tapestry of incredible diversity, from the lush canopies of dense forests to the vibrant, buzzing life of insects and the majestic presence of animals in their natural habitats. The variety of life forms on Earth is nothing short of astonishing. From the smallest insects, whose intricate behaviors and complex societies often go unnoticed, to the largest whales whose sheer size and grace inspire awe, life on Earth exists in a breathtaking array of forms. Each species, no matter how small or large, plays a unique role in the intricate web of life. But how did this incredible variety come to be? What processes shaped the myriad forms of life that we see today? These questions have fascinated scientists and thinkers for centuries, leading to numerous theories and debates. In the 19th century, Charles Darwin proposed a revolutionary idea: evolution by natural selection. This theory suggested that species evolve over time through a process where individuals with advantageous traits are more likely to survive and reproduce. This theory, with its elegant explanation for the development of life, sent shockwaves through the scientific community and beyond. It challenged long-held beliefs and provided a new framework for understanding the natural world. One scientist, Ernst Haeckel, was captivated by Darwin's ideas and sought to provide visual evidence for this groundbreaking theory. Haeckel, a German zoologist, was deeply inspired by Darwin's work and aimed to illustrate the connections between different species. His work, however, would become embroiled in controversy, raising questions about the ethics of scientific representation and the impact of visual imagery on our understanding of the world. The debates surrounding his work highlighted the challenges of accurately representing scientific concepts. Haeckel, a German zoologist and fervent supporter of Darwinism, believed that the development of an embryo mirrored the evolutionary history of its species. This idea, known as the biogenetic law, suggested that the stages an embryo goes through during development reflect the stages of evolutionary history. He called this idea the biogenetic law, famously summarized as ontogeny recapitulates phylogeny. This concept proposed that the development of an organism, ontogeny, mirrors the evolutionary development of the species, phylogeny. To illustrate this concept, Haeckel created a series of drawings that compared the embryos of various vertebrate species, highlighting their supposed similarities during early developmental stages. These drawings were intended to show that all vertebrates share a common ancestry. These drawings, published in 1868, would become both famous and infamous. They were widely circulated and used in educational materials, becoming iconic representations of evolutionary theory. They were hailed by some as powerful visual evidence for evolution, offering a compelling glimpse into the shared ancestry of different species. Haeckel's illustrations provided a visual narrative that supported Darwin's theory and made the concept of evolution more accessible to the public. However, Haeckel's work would soon attract criticism from other scientists who questioned the accuracy of his drawings and the validity of his claims. Some argued that Haeckel had exaggerated the similarities between embryos to fit his theory, leading to accusations of scientific misconduct. Despite the controversy, Haeckel's work sparked important discussions about the role of visual representation in science and the ethical responsibilities of scientists. His drawings, while flawed, played a significant role in the history of evolutionary biology and continue to be a topic of study and debate today. Today, Haeckel's drawings are used as a case study in scientific ethics and the importance of accuracy in scientific communication. They remind us that while visual aids can be powerful tools for understanding, they must be used responsibly and with integrity. The story of Haeckel's embryos is a testament to the enduring quest for knowledge and the complexities of scientific discovery. It highlights the importance of critical thinking and the need for ongoing scrutiny in the pursuit of truth. As we continue to explore the natural world and uncover its secrets, we are reminded of the incredible diversity of life on Earth and the intricate processes that have shaped it. The journey of discovery is ongoing, and each new finding adds to our understanding of the tapestry of life. Haeckel's embryos were not photographs, they were meticulously crafted illustrations based on his observations of actual embryos. These illustrations were not just simple drawings, they were detailed and precise representations that aimed to capture the essence of the developmental stages of various species. He used a technique called lithography, which involved drawing on a flat stone surface with a greasy crayon and then treating the stone with chemicals to create a printing plate. This method was revolutionary at the time and allowed for the mass production of images, making scientific knowledge more accessible to the public and other researchers. This method allowed him to produce multiple copies of his drawings for wider dissemination. The ability to replicate his work meant that Haeckel's ideas and observations could reach a broader audience, influencing both the scientific community and the general public. Haeckel began by collecting and preserving embryos from various animals, including fish, salamanders, turtles, chickens, pigs, cows, rabbits, and humans. Each specimen was carefully selected to represent different stages of embryonic development, providing a comprehensive view of the similarities and differences across species. He then carefully examined these specimens under a microscope, making detailed sketches of their features at different stages of development. This meticulous process required not only a keen eye for detail, but also a deep understanding of embryology and anatomy. Using these sketches as a guide, he created the final illustrations that would become known as Haeckel's Embryos. These final illustrations were a synthesis of his observations and artistic interpretation, aiming to convey the developmental processes in a clear and visually appealing manner. The process of creating these illustrations was laborious and time-consuming, requiring a high level of artistic skill and scientific knowledge. Haeckel's dedication to his work is evident in the intricate details and accuracy of his drawings, which continue to be studied and admired to this day. Haeckel's talent as a draftsman is undeniable, and his drawings possess a certain aesthetic beauty that undoubtedly contributed to their popularity. The artistic quality of his work helped bridge the gap between science and art, making complex scientific concepts more accessible and engaging to a wider audience. However, the accuracy of these illustrations would become a point of contention, with critics accusing Haeckel of manipulating the drawings to fit his preconceived notions about evolution. Some argued that he exaggerated similarities between different species embryos to support his theory of recapitulation, which posited that the development of an embryo, ontogeny, mirrors the evolutionary development of the species, phylogeny. Despite the controversy, Haeckel's work had a profound impact on the field of embryology and evolutionary biology. His illustrations sparked debates and further research, pushing scientists to explore and understand the complexities of development and evolution more deeply. Today, while some of Haeckel's conclusions have been revised or refuted, his contributions to science and his innovative approach to illustrating embryonic development remain significant. His work serves as a reminder of the importance of both observation and interpretation in scientific inquiry. Haeckel's embryos continue to be a topic of interest and study, illustrating the enduring legacy of his work and the ongoing quest to understand the mysteries of life and evolution. To understand the controversy surrounding Haeckel's embryos, it is essential to consider the scientific and social context in which they were created. The 19th century was a period of immense scientific discovery and intellectual upheaval. It was a time when the foundations of modern biology were being laid and new ideas were challenging long-held beliefs. Darwin's theory of evolution, though gaining traction among scientists, was still met with resistance, particularly from religious groups who viewed it as a challenge to their beliefs about creation. The idea that all species, including humans, shared common ancestors was revolutionary and controversial. It sparked intense debates and was seen by many as a direct threat to the traditional religious narrative of creation. Haeckel, a staunch advocate for Darwinism, was eager to provide further evidence for this revolutionary theory and counter the arguments of its detractors. He was not just a scientist, but also a passionate communicator who wanted to make the complex ideas of evolution accessible to the general public. His work was driven by a desire to show the interconnectedness of all life forms and to demonstrate the validity of Darwin's ideas. The 19th century was also a time of great fascination with the natural world. People were collecting specimens, exploring new territories, and discovering new species at an unprecedented rate. This era of exploration and discovery fueled a public appetite for knowledge about the natural world and our place within it. Natural history museums were becoming increasingly popular, and the public was eager to learn about the diversity of life on Earth. These museums served as educational hubs, where people could see firsthand the wonders of the natural world, from exotic animals to intricate fossils. They played a crucial role in disseminating scientific knowledge and sparking curiosity about the natural world. Haeckel's drawings, with their striking visuals and seemingly compelling evidence for evolution, tapped into this fascination and quickly gained widespread attention. His illustrations were not just scientific tools, but also works of art that captured the imagination of the public. They provided a visual representation of the idea that all life forms are connected through evolution. They were reproduced in textbooks, scientific journals, and popular magazines, spreading the idea of evolution to a wide audience. Haeckel's work became a key part of the educational curriculum, influencing generations of students and scientists. His drawings were seen as definitive proof of the evolutionary process and were used to teach the principles of biology and evolution. However, the very features that made Haeckel's work so appealing, its simplicity, clarity, and visual impact, also made it vulnerable to criticism. As the scientific community scrutinized his drawings more closely, questions began to arise about their accuracy. Were these illustrations true representations of the embryos, or had Haeckel taken artistic liberties to make a stronger case for evolution? Scientists began to question whether the drawings accurately represented the actual differences and similarities between embryos of different species. Detailed examinations and comparisons of real embryos revealed discrepancies that suggested Haeckel might have exaggerated certain features while downplaying others. This led to a broader debate about the integrity of scientific illustrations and the importance of accuracy in scientific communication. Some argued that Haeckel had exaggerated certain features while downplaying others, effectively manipulating the evidence to fit his theory. This controversy highlighted the challenges of balancing scientific accuracy with the need to communicate complex ideas to a broader audience. It also underscored the importance of critical scrutiny and peer review in the scientific process, ensuring that findings are robust and reliable before they are accepted as fact.